All right, lesson 6.3, we're going to look at some properties of slope. We've been discussing how the rate of change can be expressed as the slope, which is the steepness of a line on a graph. And so today we're going to just take it a little bit further and look at some special cases of slope and different properties that it might have. So our big idea today, the slope of a line can be determined by examining a graph. Only one line through a point has a particular slope. Let's think about that statement for a second. Only one line through a point has a particular slope. So if you put a point anywhere on the graph and you tell me that there's a certain slope of a line that goes through it, there's only one line that has that slope, because as soon as you change the slope, you've created a new line that's not going to fall in the same spot. Okay, so only one line through a point has a particular slope. Quick definitions here. You may have pulled these from the book already, and if not, we're not going to go directly to the definition from the book. We're going to just talk about what these are. So we have horizontal and vertical lines. We've talked about what those equations look like. So if we have a line that goes straight side to side and hits the y-axis, it's y equals 5 or whatever it is. And if it's a vertical line, hits the x-axis only, it's x equals wherever it hits the x-axis, so 6. So anywhere on that line, the x value is -6, or anywhere on that line, the y value is 5. All right, but what do they have as a slope? So if we have a horizontal line, remember slope measures how fast this line is going up or how fast this line is going down. This line is not going up, it's not going down, but it can be measured. You can measure how fast this is going up or down. The value is 0, so there's 0 slope here. Now, what about vertical? If you have a line that's straight up and down, so I would say it's going down. You could also argue it's going up. You can't really defend either one. And even if you say it's going up and I ask you by how much, put a number to it, it's impossible. It's going straight up. It's not measurable. Okay, this is an undefined slope. Any other slope can be measured. It's going up by this amount, it's going down by this amount, or it has a 0 slope. It's not going up or down. This is arguably going up and down, and you can't tell me how fast or how slow. It's just straight up and down. Okay, so that's undefined. Let's think about how this works mathematically now. So your slope, we know, is y2 minus y1, x2 minus x1. What this actually represents, we've talked about, is the change in the y and the change in the x. And your change in your y is your up and down motion on the graph. Change in the x is side to side. And we're going to start using some words to describe those up and down and side to side. So the change in y, which represents the movement up and down, we're going to call the rise. And this is called the run, side to side. So rise goes up or down, depending if it's positive and negative. But run always goes to the right. So we're working left to right. And that's important. Sometimes students, they go up and then they go to the left. We're never going to work left with these lines unless we're working backwards. And that's a special case. But we're always working from left to right on the graph. All right, so let's think about the numbers now. Why does this work? So change in y. This horizontal line, if you think about it, as it goes across the graph, change in y means how much is it going up, how much is it going down. That's a value of the change in y is 0. And the change in x can be anything, because depending on how far your 2 points are, you can pick any 2 points on this line to measure the slope. It could be anything. So let's say it's 5. And 0 divided by 5 is just 0. But what happens on an undefined slope? So we've got 2 points on a line that's going straight up and down. So the change in y could be any number. So let's say I had a point here and a point here, and they're 6 units apart. My change in y can be 6, but my change in x, my run, from a point here to a point here, how much has it gone from left to right? It hasn't. So the change in x, the run, is 0. And when you think about this mathematically, I'm not allowed to divide by 0. 6 divided by 0, you can't do that. It is undefined. So that's how this ties into the mathematics of this. All right, so we only have one example to look at. Putting some points on the graph and then using the slope to come up with more points and a line. So graph and label each line that passes through the given point with the given slope, and then give another ordered pair with integer coefficients that's also on that line. Integer, remember, whole numbers, they can be positive or negative, but if they're integers, that means they're not fractions or decimals. So we're not going to give a point on a line that's like 3.5 or something like that. It's got to be a whole number. All right, so starting with letter A, point -3, 6. So always remember it's x and y. So x, if we want to label it, and y, those are our axes. So if it's -3, starting at 0, 1, 2, 3, -3, and then +6, 1, 2, 3, 4, 5, 6. So that's the point -3, 6. And now it has a slope of 1/4. Now that's a small slope, but it is positive. So as I go from left to right, a positive slope climbs up that graph. Okay, we're going up the mountain if it's a positive slope from left to right. So this is your rise, and this is your run. So remember, rise, if it's positive, is going up 1, and your run is always going to the right, and it's 4. So the rise is 1, the run is 4. From this point, we're going to rise 1, so it'll go up 1, and run 4, so to the right 4. 1, 2, 3, 4. And so the slope between these two lines is 1/4. It's positive. It went up 1 and then over 4. We can do it again. Up 1, 1, 2, 3, over 4. Between any points on this line, it's going to have the same slope. So I can continue this up 1 over 4. And what I don't want you to do is just put 2 points on the graph and then just draw a line, because most of you are not going to draw it perfectly straight. And it's going to curve up here, and you're going to think there's a point on this line that's not actually on it. Now think about working backwards. I just kind of emphasized how important it is to work to the right, but if we're working backwards, we're going to do the opposite of this, because the next point, if I continued this line to the left, finished it off, it's not going to be up from here. It's actually going to be down, and it's not going to be to the right of here. It's going to be to the left. So we're going opposite of this to kind of work backwards. So I'm going down 1, 1, 2, 3, to the left 4, because from this new point now, it follows the correct slope, up 1 over 4. And down 1, 1, 2, 3, it would be right here. All right, ideally using a straight edge, otherwise just going very carefully. This is point A. I'm sorry, line A. And so it says graph and label each line. We did that. Then give another ordered pair that's also on the line. So this was the point that was given, -3, 6. You can use any one of these points as your answer. So let's use this one. If I'm going to give my x and y, well, my x is +1, and it's 1, 2, 3, 4, 5, 6, 7. One, 7. Okay, let's go to line B. We're starting at point 2, 5. So over 2, up 5. And now this one has a slope of -3. Now, slope is ideally given when we're putting these on a graph as a fraction. So if you get a whole number, put it over 1 to get your rise and your run. We know that a whole number actually has a denominator of 1. We just don't have to write it there. So when you give a slope, you can say the slope's -3, but when you go to put it on the graph, don't be confused. There is a 1 down there. So our change in y is -3, and our change in x is 1. Remember, this is your rise and your run. Now, since this is a negative slope, our rise is actually going down 3. Our run always goes to the right, 1. So a slope of -3 means the change in y is down 3. The change in x is 1 to the right. So from this point, I'm going down 3 because it's negative. 1, 2, 3, and over 1. Down 3, over 1. Continue that pattern. And if I'm going to work the other way, I'm going to go opposite of that. So instead of down 3, I'm going to go up 3. And now I'm going to the left 1 to continue this. And I'm going to just carefully connect these dots. Label my line. This is line B. And another point on this line, I'm going to choose this one. You could choose any one that you want. The x value is 1, 2, 3, 4, and it's down 1, so it's 4, negative 1. But again, any point on here would be fine. Now, there's going to be lots of you that mess up on drawing your lines using your slope at first. So let's say you started here. You know it's down 3 because it's negative, 1, 2, 3. But then you think, well, it's negative. Do I go left now? And so you went down 3, left 1, down 3, left 1, down 3, left 1. And then you draw your line. Think about what that line looks like. That line would be climbing up. And if that line is climbing up, it should have a positive slope. So always double check your line. Just look at it visually on the graph. If it's a negative slope, it better be going down from left to right. So you can catch your own mistake pretty quick there. Okay, if you went down 3, left 1, down 3, left 1, down 3, left 1, you've created a line that's actually climbing across your graph. And that would be a positive slope. So if it's supposed to be negative, you know you messed up. All right. Next one. 4, negative 2. So let's first find that. 1, 2, 3, 4. Negative 2. It's right here. So just below that last point. And now a slope of 0. So let's slide back up. What does a 0 slope look like? That's going to be a horizontal line. So it's 0 over something. Let's just put it over 1 for now. You can put any number down here. That's your rise and run. I know 0 is on top because mathematically I can do 0 divided by 1. The answer is just 0. It's not undefined. An undefined slope is going to have the 0 in the denominator. So 0 slope, it's not going up, it's not going down, it's going to be straight across. So technically my rise, it's going up 0, it's not moving. And my run, you can put any number down here, so I'm just going to say 1. So if I'm starting here, my rise and run, my rise is 0, my run is 1. My rise is 0, my run is 1. And now you don't have to go through that whole process once you fully understand it. But for now, you may want to still put a couple points there. But as soon as you see slope of 0, that's a line that does not go up or down. Slope of 0. And if it's going through that point, 4, negative 2, it's going to look like that. Let's label it. That's line C. And another point, it could be any point on this graph, so I'm just going to choose this one right here. It has an x value of 0 and a y value of negative 2. All right, last but not least, let's put one that is undefined on here. So starting at point negative 1, negative 7. So left 1 down 7 from your origin, 0, 0. An undefined slope, that's a line that's going to look like this. In terms of your change in y and your change in x, or your rise over run. Undefined happens when there's a 0 in the bottom. So since it's going straight up or down, there is no run. It's not going left. It's not going right. And the rise can be measured between any 2 points. So I'm just going to put a 1 there. Again, you can put any number you want there. So starting at negative 1, negative 7, my rise, so up 1 over 0. So if I go up 1 over 0, it's right here, up 1 over 0, up 1 over 0. It's going to be this vertical line that goes all the way up the graph. And it's never going to leave that x value of negative 1. So there's line D. Remember what the equation of this line is. If it's straight up and down, it's going to hit that x-axis. And anywhere on this line, it's x equals -1. Remember this line, it's going to hit the y-axis. And this is y equals -2, because anywhere you go on this line, the y value is -2. The x value is changed. The y value is still -2. On this one, no matter where you go on this line, the x value is still -1. Okay, so that hasn't changed. Now, last thing we need to do is just pick another point that's on this line. Think about it. All of the x values are going to be -1, so it's going to be -1 something. So if I go here, or here, or here, it's still -1 for my x. And then you can literally put any y value that you want. So I'm just going to put 5. You can put any number you want. -1, 5 is up here. You could do -1, -5. It literally doesn't matter. As long as that x value is -1, it's going to be on that line.